mind-bending possibility of parallel universes. Okay, let's dive into this, because we're going to explore the absolute cutting edge of particle physics and dig into the deepest mysteries of the cosmos, just to see if a mirror universe could be hiding right next door.
I want you to imagine something truly massive for a second. Try to picture uncountable versions of Earth floating within an infinite number of universes just like ours. And within those universes, uncountable versions of you. Usually when we think about parallel universes, we kind of picture them as being impossibly far away, right? Separated by these vast, empty cosmic voids. But what if we don't have to look far at all? What if a mirror version of our reality is right here, sitting perhaps just a million trillion trillionth of a centimeter away from us right now? It's a completely staggering concept, and to understand how this is even possible, we really have to look back to the very beginning of everything.
Section 1. Beyond our space-time continuum. To really get this, we have to look at the macro scale of our universe, which, as you know, began about 13.7 billion years ago when a small, incredibly hot singularity exploded in the Big Bang.
So when we look at that massive macro scale of the cosmos, we have to grapple with the space-time continuum. It's that four-dimensional fusion of space and time. Now, if this space-time is flat and if it stretches infinitely far beyond the limits of what we can actually observe, well, a profound mathematical reality emerges. Because there are only a limited number of ways particles can actually be put together, an infinite space-time means that eventually particle configurations literally have to start repeating themselves. It's like a giant cosmic puzzle with limited piece shapes but an infinite board. This creates a reality where our universe is just a tiny fraction of what's out there, potentially holding uncountable, completely disconnected parallel realities.
Section 2. The 10-second neutron mystery. Now, what's really interesting about this slide is how we actually search for this stuff in the real world.
We are not just doing theoretical math on a chalkboard here. We're actively zooming all the way down to the microscopic quantum realm in actual physical labs to see if we can, knock on the door of a mirror universe. Over at Tennessee's Oak Ridge Laboratory, a team of physicists is trying to do exactly that, and they are using an incredibly powerful 85-megawatt nuclear reactor to do it. The experiment itself sounds deceptively simple, but it requires mind-boggling technology. Step 1. Fire billions of neutrons on command. Step 2. Direct that massive beam of particles straight at a solid, impenetrable wall. Now, according to standard physics, obviously none of those neutrons should pass through. But step 3 is where the magic happens. If any neutrons do manage to make it to the other side of that wall, it would mean they actually transformed into mirror images of themselves just to pass through the barrier between the two worlds.
Now, you might be wondering, why on Earth would physicists even suspect that neutrons can do this? Well, we have a massive detective clue just staring us right in the face. It turns out there is something very, very odd about neutrons. When you measure neutrons traveling in particle beams, on average, they last for exactly 14 minutes and 48 seconds before they decay into protons. But, and here's the kicker, if you take those exact same neutrons and place them in a laboratory bottle, they break down 10 seconds faster. And remember, neutrons are entirely identical. They are literally all exactly the same. There should be absolutely no 10-second difference in their lifespan, regardless of how they are stored. Yet, there it is. A 10-second anomaly that we absolutely cannot explain with our current laws of physics.
This unexplainable 10-second gap has led to a breathtaking hypothesis. Could it be possible that these neutron experiments didn't go as expected because physicists accidentally opened a microscopic portal to a mirror world? I mean, think about it. If neutrons are actually slipping back and forth between our universe and a mirror reality, it would perfectly explain the missing time in their decay rate. This anomaly could literally be the very first tangible evidence that a mirror universe exists right next to our own, complete with its own mirror atoms, just completely cut off from our view.
Section 3. Odds of a mirror Earth. So, the crucial point is,
If there are mirror atoms, does that automatically mean there's a mirror Earth out there where you could step through a portal and high-five an identical version of yourself? Well, to build an identical mirror Earth, you have to consider the sheer scale of our universe. The number of particles in our observable universe is estimated to be a 1 followed by 9,000 zeros. Just let that sink in for a second. It is mathematically staggering.
So, for a mirror Earth to exist where another version of you is walking around right now, every single one of those particles, all 1 followed by 9,000 zeros of them, would need to have had the exact same interactions for 13.7 billion years. Because of this, while parallel universes likely do exist, the odds of finding a portal to one that is exactly identical to ours are, unfortunately, pretty much zero.
It's far more likely that nobody has detected a mirror particle yet because this mirror world operates under its own distinct, entirely different mirror laws of physics.
Section 4. Dark matter and microportals. Let's move to and see how this builds.
If we leave the laboratory behind for a moment and look back up at the cosmos, these mirror particles might actually be hiding the single biggest secret in astronomy. You see, our universe is dominated by something called dark matter. We can't observe it directly, we have absolutely no idea what it's made of or how it even works, but we can see its gravity. We know it acts as the ultimate cosmic glue. It's this unobservable force that's literally strong enough to stop spinning galaxies from just flying apart into deep space. And yet we cannot find it anywhere. A growing theory suggests that the reason we can't find dark matter is because it's actually leaking into our reality from a mirror world.
And this brilliantly illustrates the scale of what we're dealing with. When we map the universe, we find there is 5 times more dark matter than there is visible matter. Every single star, planet, dust cloud, and galaxy you can see only makes up 1 part compared to the 5 parts of dark matter holding the whole shebang together. If dark matter really is the gravitational shadow of a mirror universe leaking into ours, well, that means that mirror universe is vastly more massive than the one we live in.
But hey, before you pack your bags to go visit this massive mirror realm, we have to ground ourselves back in the microscopic reality. As the explainer's source material points out, even if we definitively opened a gate into another world, the portal would be incredibly small. You couldn't see anything at all without immense, highly powerful laboratory equipment. We are dealing strictly with the realm of neutrons and protons here. You could only enter that realm if you possess the sci-fi ability to shrink yourself all the way down to the size of an atom.
Which brings us to the ultimate realization today. We are surrounded by forces we just cannot see, and we're constrained by boundaries that might be far more porous than we ever believed. From an 85-megawatt reactor in Tennessee to the gravitational glue holding distant galaxies together, the evidence is absolutely mounting that our reality is just a fraction of the whole. So I'll leave you with this. The next time you look up at the night sky, or even just think about the atoms making up your own hand, ask yourself, are unseen, invisible forces from a mirror universe leaking into our world right now? It kind of changes how you view everything around you, doesn't it? Keep asking questions and never stop wondering about the universe next door.